All right, so here are the solutions to our warm-up. So when we're factoring out a monomial, one term, making sure we're using the greatest common factor, if I'm looking at 48, 16, and 2 on our factor sheet, we should have used 2 as our greatest common factor, okay? And then making sure we are putting in those terms in our box. And we're factoring out a 2. We are not able to factor out an x because the last term does not have at least one x. So then remember, when we factor, we're dividing, okay? We take 48 divided by 2, which is 24. And then because we are not taking any x's out, the x's that were in the box are going to stay the same amount. Negative 16 divided by 2 is negative 8 x squared, and then 2 divided by 2 is positive 1. All right, number 2. Greatest common factor of 35, 20, and 25 is 5. So this one, we're going to need 4 sections to put our terms in. And our greatest common factor of those 4 numbers is 5. And then if I ask myself, how many x's do all 4 boxes have at least? The first box has 4, then 3, and then 2, and then 1. So they all have at least 1 that we can factor out, 1x. So we're going to factor out a 5x, which means I'm taking each of those terms inside that box divided by 5x. Remember, we divide our numbers, we subtract the exponents. So our 5x goes down in our answer. Oh, back at number 1, I forgot to put our number we factored out in front. So if you did not yet do that, please do so. All right, we have our parenthesis. Now I just take 30 divided by 5, which is 6, x to the 4th, and I take 1 away, I have x to the 3rd. Negative 5 divided by 5 is negative 1. X to the 3rd, take 1x away, I'm down to x to the 2nd. Negative 20 divided by 5 is negative 4. X to the 2nd, take away an x, I have only an x left. And 25 divided by 5 is 5. If I had an x, I took an x away, I don't have an x anymore. So just 5 there. And that is our answer. All right, number 3, 14, 2, 8, and 20. Our greatest common factor of those 4 numbers is going to be 2. 2 is the biggest number that can fit perfectly into all 4 of those. So we're going to factor out a 2. And if I look, my first box has 5 x's, second box has 6, then 3, and then 1x. So they all have at least 1. If I were to try to factor out more than 1x, that last box, it would not work because there is only 1. Y's, I have 3, 1, 4, and 1. So they all have at least 1 y. So we're going to factor out a y as well. So remember, we drop what we're factoring out in front, and then we divide our numbers, subtract the exponents from like bases. 14 divided by 2 is 7. If I had 5 x's and I took 1 away, I now have 4. If I had 3 y's and I took 1 away, I now have 2. 2 divided by 2, our middle term is 1. 6 x's minus an x is 5, so x to the 5th. And here the y's are going to cancel. I had 1 y, I take 1 away, they just cancel each other out. So that's all I have for my middle term, or my second term. My third term, 8 divided by 2 is 4. X to the 3rd, take an x away, I have x to the 2nd. And then I have a y to the 4th, take away a y, I have a y to the 3rd. And then our final term, 20 divided by 2 is 10. I had an x, I took an x away. I had a y, I factored out a y. So the x's and the y's cancel each other out. We're left with that. All right. Okay, number 4. We got 24x to the 4th, negative 9x to the 3rd, and 33x. So if I think about 24, 9, and 33, our greatest common factor is 3. And then if I look at my x's, I have 4 x's, 3 x's, and 1 x. They all have at least 1 x, so I can take out an x as well. So we're going to factor out a 3x. So we're dividing our numbers by 3 and subtracting the exponents from our x by 1 here. So 24 divided by 3 is 8. I had 4 x's. I'm taking an x away. I now have 3. So x to the third. Negative 9 divided by 3 is negative 3. X to the third, take away an x, I have x to the second. And then 33 divided by 3 is 11. I had an x, took an x away. There are no more x's. So those are our solutions for 1 through 4. And if you flip the page, say this is review of simplifying expressions when we have fractions, okay? So we look to reduce our numbers, subtract the exponents, okay? And then I ask myself also, if I have like bases in the numerator and the denominator, where I have more of those bases at. And then that's where my variable will go. So if I had more x's in the denominator, I would keep my x's in the denominator. If I had more x's in the numerator, I would keep my x's in the numerator. But once again, look to reduce numbers, subtract the exponents. So on number 1, my normal number, I have a 3 on top. There's nothing on the bottom in the denominator, so I keep 3 in the numerator. And then I have 5 x's being multiplied in the top and only 3 in the bottom. So I have more on top, so they're going to stay on top. 5 minus 3 is 2. There are 2 more on top. And then we could put over 1, or we could just have 3x squared. Either one's fine. Okay, looking at number 2, just look at the numbers, okay? Just the integer numbers, okay? They're in the fraction. So we want to look to reduce them using the ABC key on our calculator. So negative 5, and then you'd hit your ABC key in 10. It's reducing it and simplifying your fraction to negative 1 over 2. Now I try to take care of my a's. I have 3 on top, 2 on the bottom, more on top by 1. Could left it just a if you would like. And then b's, a 1 on the top, 5 on the bottom, so there are more on the bottom. If there were 5 on the bottom and 1 on the top and I subtract, 5 minus 1 is 4. So there are 4 more on the bottom. All right, just look at those numbers. 20 over negative 8. Look to reduce them, okay? If you just use your ABC button on your calculator and simplify it, okay, it will give you probably a mixed number, actually, yeah. So then if it does give you a mixed number, make sure you hit Shift ABC, okay, and it will turn it into an improper. So 5 over negative 2. If you have negative 5 over 2, that's fine as well, as long as there's a negative involved. X's, 1 on the top, 5 on the bottom. There are 4 left more on the bottom. Y's, 3 on top, 1 on the bottom. There are 2 more on top. And Z's, 2 on top, 2 on the bottom, so they actually cancel each other out. There are no Z's. All right, number 4, last one here. We'll look to reduce 12/18. Okay, once again, using your ABC button on your calculator helps you simplify it. We get 2/3. And then A's, 6 on top, 7 on the bottom. There are 1 more on bottom. B's, 3 on top, 2 on the bottom, 1 more on top. And C's, there was 1 on top, nothing on the bottom, so it's just going to stay on top. And those are your solutions for your bell work answers. And then you guys can go ahead and pass those forward once all of those have been corrected and fixed if needed. And then we'll take some time to get our notes passed out. All right, so our notes today, we got a little bit newer lesson. So we're just going to do these examples together. Just make sure you're writing these down along as I'm going through it. And if we need to pause the video, definitely feel free to take the time to do so. So what we're going to do, kind of similar to when we multiplied, we're going to still make our box. We're going to use the box method here. But instead of multiplying, we're going to factor. And when we think of factor, we more so think of division. Okay, but with multiplying, we filled our outsides. Okay, I'm going to put stars where we put our terms, like out here, and then we multiplied to get our insides. Okay, with factoring, we're going to fill in the inside, and then we're going to factor to get our outside. So we're going to fill in our inside first, and then we'll find the outside, and this time the outside will be the answer. Okay, unlike with multiplication, we filled the outside, got the inside, and the inside was our answer. So here, first term will always go in the top left box. My first term is n squared. My last term will always go in the bottom right box. And then we're gonna have to remember when we did those Tough 2 worksheets where it had to multiply together to be a certain number and then add together to be a different number, okay? That's what we're gonna think of. This middle term right here that I'm circling, okay? Actually, I'm gonna go back. We need to multiply these two numbers. Now, if I think about the number in front of n to the second, okay, what is the coefficient or the number out in front of the n to the second? Well, there's one n to the second. So you're really thinking of this as a 1, and you're going to multiply it by the bottom right, negative 15. Well, 1 times negative 15 is negative 15. So this number right here is what you're looking at on your factor sheet, okay? If you need an extra copy, I have extra copies. Make sure you get one for this lesson. So you're looking at the 15 on your factor sheet. Okay, the pairs. If you look at that, you have 1 and 15 and 3 and 5. Those are our only two answers. So that means those two pairs, I'm going to star this here, will go here and here. Okay, so it's either going to be 1 and 15 that go in those two star boxes, or a 3 and a 5. Now, they might not all be positive. There might be like 1 negative and 1 positive. Okay, so to know which pair to use, the 1 and 15 or the 3 and the 5, we look right here at that middle term. They need to add to get negative 2, okay? So on this problem, the two numbers need to multiply to get negative 15. That's where this is coming from. And they need to add to get negative 2n. That's where that one is from. Okay? Well, if I think of 1 and 15, okay? If I were to take maybe 15 and plus 1, that's 16, not negative 2. That wouldn't work. If I were to try to take 15 minus 1, that's 14. So that's not going to work. So it's going to be the 3 and the 5. Okay? So if I did positive 3 and positive 5, well, that's 8. That doesn't work. So maybe I need to put a negative on one of those. If I do a positive 5 and a negative 3n, that's positive 2n. So, hey, we got the right number, we just don't have the right sign. So maybe if I flip those signs, maybe we do a negative 5n and a positive 3n. These two numbers right here need to multiply to get that, negative 15, and add to get negative 2n. If I did 3 times negative 5, that gets me negative 15, so it checks there. And then if I do 3 plus negative 5, that gives me negative 2. And I should say 3n plus negative 5n, which is negative 2n. So it checks out there as well. So we know those are the correct numbers. Now what we have to do is factor out each row. So I'm going to factor this row and put right here. I know I'm kind of making this kind of messy for you. This one goes right there. This row side to side goes right here. And this one side to side goes right there. So I'm just going to rewrite this nicely for you since I kind of scribbled a lot. We have 1n squared. We wrote a negative 5n, a negative 15, and a 3n. So right here in that dot that I made, we're looking at the 1n squared and the 3n. If I'm asking myself, what is the biggest number that I can factor out of 3 and 1? Okay, the biggest number that can fit perfectly into 1 and 3 is 1. And then I look to factor out an n. If I have an n to the second and an n, well, they both have at least one n, so I'm going to factor out an n as well. So 1n goes in the top left. Now I'm going to put my next one where I put that star. Okay, I'm going to look at the negative 5n and the negative 15 to figure out where what I factor out, and I'll put it in place where that star is. 5 and 15. The biggest number that 5 and 15 share or have in common is 5. Do they both have an n? No. So I'm going to factor out just the 5. Now, here's the catch. Are those both negative? In this case, they are, so you know it's going to be negative. Okay? Now, top row, I'm going to put where this star is. I'll put my answer eventually where I just put that star. I'm looking at 1n squared and negative 5n. Okay, if I think about the numbers 1 and 5, the biggest number that goes into 1 and 5 is 1. And then I ask myself, do they both have an n? Well, here I have an n to the second, so 2 n's. Here I have 1 n, so they both have at least 1 n. And then last one, I got to fill in that star. I look at the number 3 and the number negative 15, or 15. So 3 and 15, the greatest common factor that 3 and 15 have is 3. And that is our answer. And then the last thing we need to do is put parentheses around those binomials. I guess I can't really do it the vertical one. So, but you'll write your answer as 2 binomials side by side. And it doesn't matter if you put this one first or this one first, as long as you both have them side by side. So I could do 1n minus 5, and then right next to it, 1n plus 3. And that is what our answer will look like. Okay? All right. Let's do number 3 now. Okay? I'm going to skip 2, we'll go 3. Make our box method. Okay, we said the first term goes in the top left, y squared. The last term goes in the bottom right. Okay? And then now all we have to do is multiply. Remember, this is a 1 out in front, times 6. You take your normal number, your integer numbers, and you multiply them. Okay, we take 1 times 6, which is 6. Okay, so we know that's the number we're looking at on our factor sheet. So you're looking at your 6. As you do that, you should see a 1 and a 6 and a 2 and a 3. Okay? That's what will go here and here. Either 1 and 6 or 2 and 3. Maybe one of them's negative, maybe both are negative, maybe both are positive. But it'll either be 1 and 6 or 2 and 3. And remember, they have to add to make our middle term 5y. Okay? So that means I will have a y on my number answer, okay, as my variable in those 2 blank spots. So if I look at 1 and 6 or 2 and 3, how am I going to get 5? Well, if I think of 1 and 6, well, 1 plus 6 is 7. That doesn't equal 5. 1 minus 6 is 5. So it could be 6 and negative 1. But if I put 6 and times negative 1, that does not equal positive 6. It equals negative 6. So even though 6 plus negative 1 equals 5, which works for our middle term, 5y, this 6 times negative 1 does not equal this positive 6. So we know it's not 6 and 1. It has to fit both. So let's try 2 and 3. Well, does 2 times 3 equal 6? Yes. Does 2 plus 3 equal 5? Yes. But it needs to be 5y, so we just throw a y on the 2 and the 3. So 2y plus 3y is 5y. So I put my 2y and my 3y in those 2 remaining boxes. It does not matter which box gets either of those terms. I could have flipped it around if I wanted. Now, to get this star, I'm going to factor the 1y squared and the 3y. Well, the greatest number that 1 and 3 share is 1. Greatest common factor. The most amount of y's I can take, I have 2 and 1. They both have at least 1 y. Now, top right, 2y and 6. What the greatest common factor of 2 and 6 is 2. Do they both have a y? No. So we're done with the top row. Now we're going to do the side. So where I put that star, I'm looking across the top row. 1y squared and 2y. Well, the greatest common factor is 1, and they both have a y. And then the bottom row, 3y and 6, the greatest common factor is 3. And if they both have a y? Answer is no. So your answer is what we have in purple, but you'll write them as the product, which means multiplication, of two binomials, right? Two terms in parentheses, and then the other two terms right next to it in parentheses. And then once again, it doesn't matter which order you put. 1y plus 2 times 1y plus 3. If you put your 1y plus 3 first and your 1y plus 2 second, it's okay. So those are that is the answer, okay? All right, let's do number 5. Okay, to start the problem, make your box. First term, top left. Last term, bottom right. Remember, this could be a 1 in front of that x squared, so we take 1 times 24, which is 24. That's what you're looking at on your factor sheet. So you're looking at your factor pairs of 24. So you should be seeing 1 and 24, 2 and 12, 3 and 8, 4 and 6. So your answers that will go in those remaining two boxes are either 1 and 24, 2 and 12, 3 and 8, or 4 and 6. Once again, we might have to put a negative on one or both or neither. Okay, just depending on what our middle term asks us to get. So remember, they need to add to that middle term, negative 14x. So we're trying to figure out between those four pairs and our 24, which two make a negative 14. Okay? 24 and 1, no. 12 and 2, maybe. We have a 12 and a 2. If I add those, I get 14, but I need negative 14, so maybe that one. 3 and 8, no, because that would be if I add 11, subtract 5. And then 6 and 4, if I add, I get 10. I subtract, I get 2. So we know it's got to be 2 and 12, but they have to add to a negative 14. Well, if I do 14 plus 2, or sorry, not 14. If I do 12 plus 2, that's positive 14. So if I did 12x plus 2x, that's 14x. But we need a negative 14x, so it can't be positive 12 and positive 2, okay? We need a negative 12x plus a negative 2x, which is a negative 14x. So my negative 12x and negative 2x will fill the remaining two boxes. Once again, it doesn't matter which one goes where. And once again, here we go. We just need to factor out to get our answer. So top left, right there, I factor 1x squared and negative 2x. So what's the biggest number 1 and 2 share? 1. Do they both have an x? Yes, they both have at least 1. Okay, this top right, 12 and 24. If you're looking at 12 and 24 on your factor sheet, you're trying to find the greatest number they both have. In that case, it is a 12. Do they both have an x? No. Okay, top row. 1x squared, negative 12x. If I think of the number 1 and 12, the biggest number is 1. Okay, we have an x to the second, and we have an x. So the most amount is they both have just at least one x. And then here, bottom left, I have a 2 and a 12. The greatest common factor of 2 and 12 is 2. Now what you want to do is you want to check your math, okay, and multiply back through to see if you have the right answer. So if I take this 1x times this 1x, I should get 1x squared. Well, 1 times 1 is 1, and x times x is x squared. So that's good. I take that 1x times 12, and I should get negative 12x. Well, 1x times 12 does not equal negative 12x. Okay, and we knew when I multiplied these two, it worked for that one. So we're not going to change those 1x's because those are right. What I need to have is I need to put a negative on the 12, because now if I take this 1x times negative 12, I do get a negative 12x. And then here, 2 times 1x. That's 2x, but I need a negative 2x. Once again, this one, that 1x was good. It worked for the top left one. So we're not going to change that 1x. What I need to do is I need to put a negative on the 2. Now if I take negative 2 times 1x, I do get negative 2x. And then finally, if we check, negative 2 times negative 12 is positive 24. So we know we're good. So write your answer as the product of two binomials. So I have 1x minus 12, and I have 1x minus 2. Okay? All right. We'll do one more in our notes here. Okay? Let's do number 8. Okay? So we're going to make our box. First term, top left. Last term, bottom right. Okay, we multiply here. Remember, it's a 1n squared, so you're taking 1 times negative 56, which is negative 56. And again, this is the number we're looking at on our factor sheet. Okay, we're looking at the 56 pairs. Okay, so we have 1 and 56, 2 and 28, 4 and 14, or 7 and 8. So it's one of those 4 pairs that will go in those remaining 2 boxes. And they need to add to negative 1n, right? We could sneak a 1 in front of that n, so they need to add to a negative 1. Okay? 56 and 1, there's no way we can get negative 1 there. 28 and 2, nope, can't get a negative 1 there by adding. 14 and 4, well, 14 plus 4 is 18, 14 minus plus a negative 4 is 10, so nope. Now, 8 and 7, well, 8 plus 7 is 15, but if I take 8 minus 7, I get 1. But we need is a negative 1, so that's the right number, but the wrong symbol. So we need a negative 8n and a positive 7n. That equals our negative 1n that I needed. So we can fill in the negative 8n and the positive 7n in our remaining 2. And now our last step is to factor out each column and row. So this top left, 1 and 7, greatest common factor is 1. N to the second and n, they both have at least one n, so we can factor out an n. Okay, top right, 8 and 56. If I look at my factors of 8 and 56, our greatest common factor is 8. And because they are both negative in that row, we know it's a negative. Now our top left, 1 and 8. Our greatest common factor is 1 again. And they both have at least one n. And then bottom row, 7 and 56. Our greatest common factor is 7. So our answers are what are in purple there. So we have 1n minus 8 and 1n plus 7. Okay. If the teachers feel like we need more practice with this, we can do some more examples. Otherwise, we have an exit ticket we can do, and then you guys can begin on your assignment.